all the drafts of kinematics, and we've also discussed equations of motion of straight lines. Yes, this is all that we've talked about up till now. Um, Falling objects, this is very interesting case to come when we talk about kinematics because अब specifically for this topic, we're looking at objects falling vertically, ठीक है? एक specific surface है, and then objects coming down, or even, yeah, it's majorly a vertical downward motion. And there are basically two cases that we're going to be studying. For example, the first one is called a free fall motion. Free fall motion is also known as a uniformly accelerated motion. Why do we call it a uniformly accelerated motion? Because, one second, because of the characteristics of this motion. For example, अगर होता है कि free fall में there's no resistive force that acts on an object when it falls down, right? इसलिए we call it a free fall motion. That there is no force that resists the motion of this object. For example, a ball falls downwards towards the ground. There's only one force acting downwards, that is the weight of this ball. And there's no other resistance force. There's no air resistance. There's no drag force acting against it that resists the motion, right? So the
Right.
only
Okay.
acceleration that it has is due to the gravity. And gravity, which is 9.81, so this is the only acceleration, 9.81 meter per second square. So at every second, it accelerates 9.81 meters. This is what it means. A free falling object is an object which is falling under the sole influence of gravity. So only falling under the influence of gravity is basically the free fall motion. An object which is being acted upon only by the force of gravity is said to be in a state of free fall. So these are two different definitions that you can remember for a free fall motion. Falling under the influence of gravity only, that means no other force acts on it. Okay. Um, all objects fall freely at 10 or you could say 9.81 meter per second square. Um, s- when near the Earth, air resistance is negligible. So this gravity is constant when the objects are close to Earth and air resistance is negligible. Because air resistance is itself the opposing force. Let's say if there was to be an opposing force, it would have been air resistance. But since it's negligible, since I mean we're not considering that, so it's negligible. Speed of a free falling body increases by 9.8 meter per second every second. So at every second, the speed increases. जहाँ पे we're talking about a constant acceleration. A constant acceleration means the speed increases. I mean, you have this, I mean, you know this concept in detail, how acceleration corresponds to velocity changes. Presence of
Yes.
acceleration, constant acceleration itself means that there is a change in velocity, and that change of velocity is constant because the acceleration is constant. All right.
ठीक.
So, acha, in contrast, when a body is thrown upwards, exactly the opposite. 9.81 is the rate of acceleration, but it becomes the rate of deceleration. The speed decreases by 9.8 meter per second each second when the object is thrown upwards like this. तो यहाँ पे आके the object would become stationary and then it would start falling downwards. And then when it falls downwards, the speed starts to increase at 9.81 meter per second every second. This is why ऊपर
So,
जाते हुए the deceleration is 9.81 and नीचे आते हुए the acceleration is also 9.81.
so if there's a question और उसके अंदर मतलब it's worded in a way कि फिर ऊपर जा रहा है and then नीचे and then an object is falling down as well, तो फिर जो 9.81 जब ऊपर जा रहा होगा जब deceleration हो रही है we would have to put in minus.
Yeah, if you're calling it an acceleration, so you can say it's negative
Yeah.
9.81 meter per second square acceleration. But if you're calling it a deceleration, so you don't have to write negative because deceleration itself is negative acceleration.
Okay. ठीक.
Acha. Um, okay. Examples of objects in free fall. Number one, spacecraft in space with its rockets off, for example, in a continuous orbit or going up for some minutes and then down. For example, where a spacecraft takeoff करती है, then when it comes down, this is free fall because there's no air resistance. There's vacuum in space. Moon orbiting around Earth. right? Earth है, Earth का orbit है. Now moon also moves in free fall. Examples of objects not in free fall. Standing on the ground, the gravitational acceleration is counteracted by the normal reaction from the ground. And if let's say you're stationary, you're standing on the ground, why is it not a free fall motion? Because number one, you're not falling. Secondly, the normal reaction force that acts from the ground and your weight, they both cancel out. This is the reason why you are there on the uh, ground. They're not cancelled out, sorry, they're counteracted. Weight is more. Because weight is more, that's the reason why you're there on the ground. Okay? Flying horizontally in an airplane, the wings lift is also providing an acceleration. This is also not free fall.
But
Moon move कर रहा है.
moon का तो
हाँ हाँ.
moon का तो ऐसा ना that there's no vacuum over there, there's no gravity over there. So it's just moving in a circular motion. So
But
I
there is
समझ
vacuum,
नहीं आया.
right? हम ये कह रहे हैं कि वहां पे वैक्यूम है, वहां पे एक्सेलरेशन कोई नहीं हो रही. अभी हम फ्री फॉल को we're not talking in these examples, we're not just looking at free fall in terms of vertical motion only. We're looking at free fall as in where acceleration is and where there's no acceleration. Now, whether that's an orbital motion, whether that's a vertical motion. Okay.
Okay.
So they're differentiating in terms of acceleration. If you look at this airplane example, airplane moving horizontally, yeah, moon एक instantaneous अगर velocity आप देखो इस point पे तो भी horizontally होगी इस तरह से. But airplane has acceleration because जो lift force है due to the wings, it provides acceleration. Moon पे नहीं है because it's in a vacuum. So this is how these two examples differ. Okay. Now, representing free falls by graphs, this is a very standard representation of free fall motion on a graph. There's time axis, there's displacement on the y-axis, and if you imagine that a ball sort of falls from the top and reaches ground. Now, there's no acceleration. I mean, there is acceleration. There's no counter action force. There's just one weight that acts downwards. So what's happening here is that the object here starts from a particular displacement. And if you understand this entire particle chunk, I'm just naming it x, this is the displacement. So you start from displacement x, assuming कि ये यहाँ पे इसकी value है, and as you fall, you see there is acceleration. Um, this is a graph. This is a gradient that shows that number one negative velocity है, ठीक है, because the position sort of decreases करते करते जो displacement है वो zero हो जाती है, and that would show that it touches the ground at zero displacement. It has covered all this distance. It starts slow, but it becomes अब ये जो this is like an increasing gradient graph for falling objects. This is an increasing gradient graph for object. Let's say अगर ये ऊपर जा रहा होता, because it's coming down, this gradient is inverted. So this is
Okay.
what? This is an increasing gradient. So this just goes to show that initially it started slow, but gradually the velocity started to increase. Why was the velocity increasing? Because there was a constant acceleration of 9.81. ठीक है, अगर इसका
Okay.
acceleration time graph बनता तो acceleration time graph बिल्कुल इसका यूं बनता 9.81 पे, एक constant acceleration जा रही होती. I'm just giving you an idea. Okay. Okay, now the question is, doesn't a more massive object accelerate at a greater rate than a less massive object? What do you think? अगर दो objects भी गिर रहे हैं, if, let's say we differ the sizes of these two balls and they're falling down, do you think their masses would affect the acceleration capacities of these two objects?
No, because the gravity, the acceleration that they're falling with is 9.81 equal.
Yeah. So, because the gravity is the same, so आपकी acceleration नहीं change हो रही. Free fall is the motion of objects which move under the sole influence of gravity. Free falling objects do not encounter air resistance. More massive objects will only fall faster if there is an appreciable amount of air resistance present. Exactly. So there has to be an ideal situation for this particular scenario to be true. When two objects fall solely under the influence of gravity, they fall down at the same pace. But जरा सी भी air हुई, resistance होगी जिसकी वजह से they will the time they would take to touch the ground would be different. अच्छा, clear up till now? यहाँ तक?
Yes. Yes.
Now, again, यहाँ पे what's happening here is this is the second type of motion that is falling under the influence of gravity. Force of gravity means the dog axis. I don't know why they're throwing the dog down, but this example shows that the dog is falling slowly. It has not had time to speed up. Ab initially, once the dog starts to fall, gravity is the only force acting. There's really one force acting in the dog, that is the force of gravity. The dog falls faster, accelerates due to this force. Now, because there's gravity, there's acceleration, right? Because there's force. Force equals ma corresponds to acceleration. There is now acceleration, and that means the velocity of this dog would increase. Now, what happens is as the dog falls down, the dog experiences air resistance. Gravity is, you see, look at the vector arrows. The gravity is more, air resistance is less. But this just goes to show that there is air resistance, and this arrow tends to increase because the air resistance increases as the dog falls down. Um, I mean, this is just the effect of air resistance that they're showing over here. Now you see, there's this point where air resistance and gravity are equal. Why? Because air resistance has increased to an extent that it sort of balances out gravity. And what happens when two vectors are equal? Object moves with a constant speed. We know that, right? This is called terminal velocity. So this dog would arrive at this position of terminal velocity when air resistance becomes equal to the force of gravity.
Okay.
समझ आई बात?
Yes.
So what's happening here is initially the first step is that gravity is the only force acting. The dog starts to accelerate. Secondly, it experiences air resistance. The gravity starts to decrease, air resistance starts to increase until a point where gravity and resistance they become equal and the object follows with terminal velocity. And this is basically the point when the object is about to touch the ground. So you can say when objects fall under the influence, when the objects fall under air resistance or when the objects they do not fall freely, that is when these objects tend to achieve terminal velocity when they're about to hit the ground. Why? Because that is the time where air resistance is equal to the gravity. Okay, we're looking at terminal speed here. Air resistance, gravity equal हो गए, ठीक है? अच्छा, now अब हम if this is all clear, we can move forward now.
Yes.
Okay. So uniformly accelerated motion. Acceleration is defined as the rate of change of velocity with respect to time. We know that. This would mean that if an object has an acceleration of 1 meter per second square, will increase its velocity of 1 meter per second every second that it accelerates. You know that. So हमने formula, I think we've done all of this. So I'll just skip through all of this. Okay, and then the graphs as well. We have done these graphs. इसमें yeah, okay, this is important. जहाँ पे terminal velocity की बात करते हैं. This graph sort of responds to the following objects that we have just studied. Um, okay, if you look at this graph, graph of free falling, what's that? Okay, हाँ, यहाँ से शुरू करते हैं ना. Graph of free falling objects. Object falling and bouncing back. देखो अब ये क्या हो रहा है? Initially, when the object falls, जब नीचे की तरफ जा रहा होगा तो उसकी velocity increase करिए, right? To maximum value, and as soon as the object touches the ground, it would bounce back. And when it bounces back, the velocity becomes negative. So velocity has to touch zero and immediately shift to the negative quadrant. Negative quadrant में velocity का मतलब ये है कि now the direction is changed. And as the object is moving upwards now, although it's again touching the highest value for velocity, which it will when it moves upwards, but in the opposite direction. Why? Because this opposite direction shows the change of direction. And then once again, when it touches its peak, ये वो जगह है जब object दोबारा peak पर आ गया, and then it falls down, velocity की value again increases. जब वो नीचे आके touch हुआ ground को, velocity zero हुई, और फिर जब वो दोबारा ऊपर गया, velocity का sign फिर change हो गया, positive हो गया. तो जहाँ पे the direction change हो रही है, वहाँ पे the signs are changing. And this graph shows कि positive velocity, positive, negative. This shows that the object is bouncing back again and again, it's changing directions again and again.
Okay.
Okay. And you see peak value velocity it decreases every instant. क्यों? क्योंकि फिर एक टाइम पे आके उसने जीरो भी तोड़ना है, फिर उसने बाउंस कर करके आके रुक जाना है एक टाइम पे, क्योंकि दिस इज व्हाई द एनर्जी लूज होती जा रही है और फिर उसकी पीक वेलोसिटी की वैल्यू डिक्रीज करती जा रही है. एक्सेलरेशन ऑन द अदर हैंड इज कांस्टेंट. फ्री फॉलिंग की बात थी, इस वजह से एक्सेलरेशन की वैल्यू एक ही रहेगी.
ठीक है.
Okay.
Okay.
Now this one over here, you see this is basically falling under the influence of air resistance. जहाँ पे the weight of the skydiver was the only force acting. Gradually, air resistance arrived and weight was still more than air resistance. But then at a point, air resistance became equal to weight and the skydiver, it was coming down with constant velocity. So if you look at this graph is sort of an explanation of this entire motion, that initially when the skydiver started falling, the weight was the only force acting. So this is an increasing gradient of a falling object and it increases till this point until it reaches terminal velocity. ये वाला point आ गया यहाँ पे. I'm calling this A and then, so this is all part A and then this is B. So I'm going to call this B as well. Terminal velocity achieved fairly. But then after achieving terminal velocity, the skydiver opens the parachute. Parachute किया तो air resistance और बढ़ गई, right? Because the surface area has increased. There's a lot of more air resistance now. When there's more air resistance, the velocity starts to decrease. अब आपकी speed कम. आपने terminal velocity reach की. Terminal के फौरन बाद part C में आके you're decelerating because the parachute is opened up. And then for some time again you reach terminal velocity. ठीक है, ये हम यहाँ पे D part कह देते हैं because once again even if there's a parachute, the weight and air resistance would become equal and then up at a point the object would simply land, it would stop moving. Is this clear?
Yes.
ठीक है. Yeah, now what the discussion that we majorly had today was on positive and negative velocity. How can one tell whether the object is moving in the positive direction, i.e. positive velocity, or in the negative direction? How can one tell if the object is speeding up or slowing down? Okay, number one, speeding up means that the magnitude velocity is getting large. For instance, an object with the velocity changing 3 meter per second to plus 9 is speeding up. Similarly, minus 3 to minus 9 means the object is speeding up again. अब जैसे यहाँ पे I told you that at every instant the magnitude of velocity starts to decrease. It will correspond to a lesser value, an even lesser value, an even lesser value, and it might become zero. This shows that your velocity is constantly decreasing. Even if you look at it from the negative axis, a higher value, a low value, and an even lower value, getting close to zero. So this shows that the velocity is decreasing. ठीक है, ये ग्राफ्स आपको इस तरह से बता सकते हैं the object is speeding up or slowing down. अगर ये इस तरह का ग्राफ होता, यूं, फिर ये यूं, अब यहाँ पे क्या हो रहा है, ऑब्जेक्ट है स्पीडिंग अप, जो पीक वैल्यू वेलोसिटी है वो आपकी बढ़ती जा रही है. दिस इज योर एक्सेस. दिस इज जस्ट a contrasting graph to this one. Okay, now यहाँ पे फिर they're also saying कि yeah, a positive velocity means the object is moving in the positive direction. Negative value means it's moving in negative direction. अच्छा, positive negative directions कोई नहीं होती है. एक direction A होती है, direction B होती है, तो उसको just assume positive and negative by just to sort of establish a relationship between these two. So these two graphs, they all always for objects moving in positive velocity. यहाँ से और ये वाले they are for objects moving in with negative velocity. In the
ठीक
first
है.
one, the velocity is
Okay.
increasing. The second one's velocity is decreasing, getting to zero. इसमें भी the velocity is increasing, and this is the velocity is decreasing. ठीक है? So इसमें sorry, इसमें decreasing, इसमें increasing. Increasing in the negative direction का मतलब ये although peak value पे जा रही है, लेकिन in the opposite axis that shows the direction is opposite. Uh, okay. Positive and negative once again. यहाँ पे speeding up, slowing down. अच्छा, ये पीक की बात है. आगे चलते हैं. अब आगे equation of motion आ गई that we've already done. From everything that we've done up till now, is there any question?
नहीं. नहीं, there's no question.